Anders is going to give a presentation now at 2 o'clock on using custom meshes in C++ Builder XE3 for Windows 32-bit, 64-bit, and Macintosh. And he's not only going to build a math visualization example and show you how it works, but he's going to show you how to submit a C++ Builder XE3 application to the Macintosh application store. And so with that, I'll give Anders control, or he can take control.
All right, and we'll take control right now.
Yeah.
So this is live, just as David's session was before. So I wrote a couple of articles for when XE2 was released about visualizing mathematical functions by generating custom meshes using FireMonkey and C++. And of course I wrote them for Delphi as well, but this is strictly C++. So what I spent the last hour or so doing was make sure that it works in XE3 and also in 64-bit and still works on the Macintosh. So we're going to talk about this. This article is number 42114 on EDN. If you want to go find it, it's also available in my blog. I will update the Code Central submission that goes along with this as well, and then I'll put it on my blog as well. So some prerequisites for this session is that you're familiar with the basics of 3D graphics and meshes and things like that. So don't worry, I'll take you through it. So the goal here is to get an application that generates a function of 2 variables and draws it as a volume. And in this case, I'm generating a bitmap that colorizes or gives it a temperature depending on how large the y values are in this case. So the first thing we need to do is actually generate the mesh. And we can do that using tmesh. It has a data property, and the data property in turn has points and triangle indices and things like that. And what I'll be doing is looping through the plane here, in this case the XZ plane, and I'm dividing it into small squares. And in fact, since the wire mesh is consisting of triangles, I'll be splitting each of the squares into 2 triangles. Like this. So we have a point representing a corner P1, P2, P3. That's one triangle. And then we have the next triangle, which is P3, P0, P1, which is this triangle right here. And in code, of course, that becomes this. So we have X and Z of P0 is U and V, which is my variables that I'm looping through here. U goes in one direction and the other one goes perpendicular to that. Then I have a D, which is a small increment. So P1 is this one is simply adding the delta to U, and vice versa for P2 and P3, very similarly. Then we calculate the function values, the y values in this case, from each point. So we take the x coordinate and the z coordinate, we pass it to the function that we have, and then we generate the y values for all 4 points. Then for the mesh, we assign, like I said, to the data property, we have a vertex buffer property, and then there's a vertices array in there. So we tell it that these 4 points, P0, 1, 2, and 3, are the points that we're interested in right here. Then we need to tell FireMonkey or the mesh which one of these points go to which triangle. So that has to do with the index buffer property and the indices array in here. So the first triangle is, if I can paint it properly here, P1, P2, P3, like we said, so numbers become 1, 2, and 3. And like I said, the second triangle, sorry, is P3, P0, P1, so that becomes then 3, 0, and 1 right here for the second triangle. So as you can tell, we've got 4 points for each square, and of course we have 6 indices for the 2 triangles. Finally, so this generates basically this wireframe. Finally, we want to give it some color, so we want to generate the texture. So in this case, I'm going to generate a bitmap that goes from red through yellow through green through blue, etc., all the way back to red again. I do this using the HSL to RGB function, which gives me a quasi-rainbow, if you will. Not necessarily, not exactly a rainbow, but you get some nice colors this way. So this is the XE2 code. I'll show you how that changes in XE3 due to some FireMonkey implementation changes. So basically, we create a bitmap that is one line wide and 360 tall, or vice versa. And then we go through, so this is basically goes from 0 to 359 as far as degrees go, and we generate a color for each splice, if you will. So we do direct access to the pixels, which is XE2 way, which is no longer allowed, but I'll show you the changes in the code very shortly. So that's generating the bitmap itself, or the line of color here. So then we need to tell the mesh how is that going to represent, how we're going to tie the texture to the different points. And that's what we do here. We give it a point. Always the x-coordinate is always 0 because it's a line, so we're going to the first column. And then the y value is simply a value between 0 and 1. And this is a way of indexing into this bitmap. And we had 4 points, so that's the 0, 1, 2, and 3 in this case. And then we do that for every single point, of course. So here's the entire code, and then a couple of screenshots, and actually somewhere in here there's a link. So this is the link to the demo application, which is right here. So you can download that. Like I said, it's the XE2 version at this particular time. I will upload and refresh it and put the XE3 implementation in there as well. So if we now take a look at the actual project instead, I have my implementation of a couple of different functions. So let's run it first and see what it looks like, so you'll understand what's going on here. So I have 5 different functions. I have a sine function here that I can spin around and rotate, see what it looks like from all different angles. I can zoom the camera in and out. I can rotate around the other axes as well, spin around however I want to. Okay, and I have a couple of different functions in here. This exponential function of sine x minus cosine of z. I have the positive version of that as well. I have a slightly different one here as well. Happens to be symmetrical against this line. And then I have a arctan function as well, just kind of an interesting little function there. Okay, so let's take a look at what it looks like in code. So here's my 5 different functions. So depending on what I pass in, 1, 2, 3, 4, or 5, I get different function values. So this just returns a value. I pass in the number of the function, and then I have the x and z values. Not necessarily the best implementation of passing a function number by an integer here, but anyway. So then the generate mesh function, like I said before, what it does is it sets up the mesh. It computes all the number of points that we need here. So we allocate, set the length here, allocate memory for the vertex buffer and the index buffer. We create the bitmap on the fly. This is one of the changes from XE2 to XE3. In the latest version of FireMonkey, you can no longer get direct access to the bitmap unless you first map it off of the GPU to the CPU, and that's how that's what you do here. So we're going to have read-write access. We're going to stuff it into the BMP data, which is a T-bitmap data, as opposed to a T-bitmap. Then instead of directly accessing the pixel array as a two-dimensional array, what we do is we call a function on BMP data, on the T-bitmap data reference. We call setPixel instead, and we pass the x and y coordinates, just like here, 0 and k, and then instead of assigning the value here, we pass it as the third function parameter. Once when that entire bitmap access is done, we can unmap it from the CPU and pass it back to the GPU. So now the bitmap lives on the GPU once again. Okay, and then, like I said before, we iterate from from negative max x to positive plus x, and same for the z coordinates. And we set up the x's and y's for all the 4 points. We calculate the y values for all the 4 points. We assign it to the vertex buffer, to the vertices for this particular point, these 4 points. We map the colors. Those are a reflection of the y values. And then we map the triangles. And then, of course, we do it all over again for all the different points in the entire thing. Here's a slight change also from in FireMonkey from version XE2 to XE3. We used to call calc normals. In this case, we call calc face normals. There's a couple of other implementations of calculating normals as well. There's a smooth normal and a third one. Also, in the first implementation of FireMonkey in XE2, mesh and other 3D objects used to have a material property directly on them, which had sub-properties such as texture and different colors and things like that. Now we have a material source instead. So if we look at the designer, we actually have a mesh 1 material source, and we have a text 3D material source as well. The text 3D material source is used for the text 3D control that's showing you the name of the function that we saw earlier. And the mesh 1 material source is used for the mesh. So that's going to represent the bitmap. So here, what we're doing here, instead of assigning the bitmap to the sub-properties of mesh, we simply set the texture property of mesh 1 material source to that bitmap that we calculated earlier. There's only a couple of more changes in this application from FireMonkey, first version of FireMonkey to what we have now in XE3. And it used to look like this for positioning the camera. For instance, when I drag on, let's bring it up again. When I drag on this progress bar here, or track bar, I'm zooming in and out. What I'm doing is essentially moving the camera. So I was using a global function, vector 3D scale, in the past. Now in FireMonkey 2, in XE3, there are actually methods of T-vector 3D. So the camera vector is a T-vector 3D. It has a function called scale, and it scales what the current value is simply. And I'm just using the value of the track bar, dividing it by 20. So that's going to give me a value between 0 and 1 in this case. I assign that to the position vector of the camera. Okay. So let's go ahead and run this once more. As you can tell, I'm on 32-bit Windows. So I can show you all the functions again, and this is how it works right there. Now, of course, 64-bit, as it's shipping today, we can simply just switch the target platform to 64-bit Windows, recompile it, and launch it again. So it's going to compile it, link it, and launch it again. And now it's running as a 64-bit application instead, working exactly the same as a 32-bit application, of course. Yeah, I can bring up the task manager as well. So, yeah, for all the skeptics. So here we go. The IDE is a 32-bit application. MathWiz does not have a star32, so it is a 64-bit process. If I close it and I bring up the 32-bit version, you should see the star32 on there as well. So there's the 32-bit version. Okay. Then what we'll do here is go ahead and go to the Mac. So here I have set up a remote profile. So I've got I just point to 192.168.45.1, which is my Macintosh. Excuse me. Default port number. I've pulled all the C++ headers that are necessary from the Mac to the Windows machine, to the VM here, so that I can use them for the compiler, for the Mac compiler, because we are cross-compiling. The Macintosh compiler is actually running on the Windows machine. It compiles and links, and then it uses the PA server to deploy it and debug it and all that kind of stuff. So it does need those header files. We can test the connection, make sure we're connected. Okay. So I actually have on the Mac side, I have my PA server running somewhere. Right here. There's my PA server. Ignore that this beta project has expired. It's my own build here, if you will. Okay, so that's working. So I go ahead and run it. It's going to compile it. It's going to link it. It's going to go ahead and deploy it to the Mac, and it's going to launch it on the Macintosh. Okay, so we get it working. The colors are slightly different for whatever reason. Correct color is not doing the same. It seems to be doing the reverse here, if you will. Okay, so we can get all the different functions here as well. You can zoom in and out and all that kind of good stuff. So the next thing I want to show you is how to take this to the App Store. And the first thing that you have to do whenever you're going to put something in the App Store, of course, you have to join the Apple developer program for, specifically in this case, Mac OS X. If you're doing iOS, you have to join that program as well. And everything gets set up through iTunes Connect. So iTunesConnect.apple.com, I've logged in there. I have created an app record. This is all done through the web browser. I've called it Project 1. I have a bundle ID that I've just set to com.andersolson.project1.01, whatever you want to call it. The Apple ID gets generated for you. The type of application is, of course, Mac OS X in this case, and the language is English. Then I've uploaded a couple of different screenshots that are required, icons, etc. We can view the details of that. And I have put it into the state of waiting for upload. So basically requested to upload a binary. The next step that you have to do now, the rest is done from the Mac, from the desktop. So then what we have to do is specify all of these things. So under project options, we have a couple of different things that are necessary. Under the provisioning tab, these are blank by default. Mac developer profile and third-party installer profile. These are blank by default. These will match if we go and look at the keychain access. Once you become an Apple developer, you can then go ahead and download your developer certificates and your installation certificate. You have to generate these and download them from the Apple website, from iTunes, from within your developer account. So you notice here how it says third-party Mac developer application, third-party Mac developer installer. So this is my certificate that will be used to code sign the application. This is the certificate that will be used to code sign the installer. And they go over here as strings. The second thing that we need to do here is, we need to go to version info. So version info, you will need to specify your bundle identifier. This will match the bundle identifier that we had, that we created in iTunes Connect. So notice that it says com.andersolson.project1.01, just like it did here in iTunes Connect right here. That's the bundle ID. The other ones are fairly straightforward. Bundle version is, in this case, 1.0.0. We have a default category for the application, for the App Store, which is app-category.utilities. If you wanted it to be in a different category, business application or educational or whatever, then you have to look up and put in the appropriate string. And this also has to match what category you selected when you created your app directory, your app record on iTunes Connect. Okay. The next thing that we need to do is we need to supply an icon. So the icon by default is generated here, and it's called mathviz.icns. By default, it's only going to give you resolutions up to 256 by 256. So you have to add the 512 resolution and the 1024 resolution because of that's going to be the 512 Retina version. So there's a requirement now of a 512 icon and a 1024 by 1024 icon. I have pre-made those actually on. Oh no, I haven't. So this is actually a smaller. This is the default that you get. So if I now tried to submit this application, submitting the application has to be done from the application loader, which is this guy. So one more tool to keep track of. I'm already logged in. I want to deliver my application. Notice that it was project 1. Excuse me, that was waiting for upload. Application loader has already logged in and queried what apps are available for submission. I'm going to select project 1 here. It pulls down the icon from the iTunes Connect, and I can just get a visual representation and see that, okay, that's the one I want to submit. I'll go ahead and click Next. Now I'm going to go ahead and choose the application or the package, and then I hit Send. Now it's going to verify it, and it's going to say, okay, I don't have an icon. You need to have an icon that contains 512 and the 2x. This is the Retina version of that icon. So what we're going to do here is we're going to take this. Let's see, I may have to look for it. Here it is on the desktop. I have a pre-made icon file. So this is my icon file. You notice that it's 700K. So it's much larger than the other one. I'm going to copy it, and thanks to VMware, I can just paste it in here to Windows. So now I'm going to remove this MathViz ICNS file, and I'm going to rename this. The mistake that I made before was actually hit Build All, and it regenerates the icon. So this is one of the last steps you need to do. You need to supply your icon properly. Okay, so now we can redeliver the app to the Mac. Okay, so it's running. And now we can go over and go to the app loader right here, send it again. And now you'll see that it gets a step further. It creates the iTunes Connect API analysis file and all that kind of stuff. And when you're at this point, it has actually done all the local verifications that it needs to do. So your icon is correct, your bundle identifier is correct, your app category is correct, your code signed correctly with an application certificate for the application itself, and then the entire install package is code signed properly. It takes another, it says 14 seconds here, but we'll see about that. Once it gets through here, it will tell me that it succeeded, and then there will be some more server-side processing of my installer and further verifications on the iTunes Connect side on the server. Once they are passed, I will get an email to my Mac OS X developer account email address, and it will tell me that my application has now gone into review. And that may very well happen during the Q&A phase. I'll just leave this up and running, and at some point when I reload, it'll switch into waiting for review here. At that point, it's up to Apple how long it takes to review the application. Last time I did it a couple months ago, it was about a 2-week process. It may be less, it may be more at this particular time. Since I don't actually want this in the App Store, I will reject the binary myself once it goes into waiting for review state. So if I refresh here, it'll probably say something else. No, it's still saying waiting for upload because it hasn't finished yet. Okay, so with that, we'll just leave this up and running. We'll see if there's questions at this particular time.
So one thing, Andrews, can you go back to the ID and talk about the sandboxing option in the project options? I think it was.
Yeah. Under
added in XE3 as well. Under provisioning, I think.
Right here.
Yeah.
Oh, so here the sandbox, the build type. There's actually only one type right here for now, which is called OSX Sandbox, and this just tells the UI what kind of boxes are going to be here. In this case, it's the Mac developer profile and the installer profile that go here.
And that's a requirement by Apple, right?
Yeah. Otherwise, actually, you'll get runtime errors. Once this is submitted properly, I can change the binary underneath. Or I can do it with the other. I had another profile, actually. So if I change the profile to be the other one, this one, now it'll be a different scratch directory, and I'm not going to mess with the icons or anything else. So if I actually go in and reset these to the defaults, the default is actually that this is blank, for instance. Those are both blanks. Those are that's the default. If I go ahead and run it now, it's going to fail on the Mac side. We're using the Xcode command tools to code sign and sign the installer. So that will now fail. And the errors actually, this is a good example actually, the errors actually come back to the IDE on the Windows side. So you don't have to go on the Macintosh side and figure out what went wrong. It says here, unable to execute code sign, and then it has all the parameters. And it says here, this identity cannot be used for signing code. So it's actually, in this case, it's actually the empty string is actually match. It's a sub-match, partial match, actually. So it's actually finding the same certificate for both. signing the application and signing the installer. Of course, you can expand and see what every single one is doing here. For instance, putting the file over here, and this one is code signing. And we can see here that it just put in third-party Mac developer in here and nothing else.
And again, if you're going to build a Mac app and just give it to someone, you can just take a regular application bundle, right, and give it to them. You only need this sandboxing and these certificates to, if you want to try to submit it to the store, right?
Yeah. There may be other, now with the Gatekeeper, I have not investigated the Gatekeeper, but there might be other things that you can do with code signing in order to sideload an application. Otherwise, it'll tell you this application has been downloaded from the internet, et cetera, are you sure you want to run it? Or, depending on the security profile on the machine, it may actually outright not allow anything else than App Store applications.
You got a green check there.
Yeah, so now I have a green check here. So it's uploaded the package to the App Store. I hit next. It says, okay, thank you very much. You're done. And I can go and reload here. Now it says upload received. So now we're in the state where it takes another 5 to 10 minutes to run some server-side checks on this. We're past the application loader's client-side checks, and now it's going to check it on the server side and run some more testing, rigorous testing on it. Once we get waiting for review status, then we're waiting for the human to actually make sure that this is an application that does something useful and that there's not a million other apps that does the same thing in the App Store, for instance.
And the point about the icons is that's a required. The ID has a utility that will create certain size icons, right? For you, but
yes.
Now Apple has this requirement of higher resolution icons because of Retina display, right?
Yeah, and the requirement is actually for the App Store. Okay. So if we go in and
I forget the utility, but go ahead. Yep.
Excuse me. If I go in and look at MathViz 1, which was written in Delphi, but is actually available in the App Store for Mac and for iOS. If I go in and look at this one, I should be able to see it in the App Store. And this is where my my different icon sizes come into play. It's launching the App Store now. Here we go. So there is my different icons, and depending on where I am in the App Store, it will show the different icons. And of course, depending if I'm on a non-Retina or a Retina, now you'll see the non-Retina because I don't have a Retina screen and it's not going to broadcast in Retina over GoToMeeting anyway, or GoToWebinar, sorry.
And as far as creating the higher resolution icons, I mean, you can do that through tools on Windows, but there's also a utility on Macintosh, right? What's it called? Icon Compose? I forget the name of it.
Yeah, exactly. So let me go back to the one that we had here. This is the one we were submitting. So you were asking about
is it Icon Composer? Or?
Yeah, it's Icon Composer. So the icons by default are actually only up to 256 because the Windows ICO format only supports that. And we take the ICO file and we convert it to an ICNS file. Now, in order to add the 512 and the 1024, in this case, I simply just created a screenshot. So I had this, for instance, is my 1024 ping file. So this is just a ping file that was generated on Windows. This one is 1024 by 1024. This is going to become my icon. And I had a 512 as well somewhere. So if we go to my pre-generated one, we can see what it's going to end up looking at. So if we double-click on that, it launches Icon Composer.
Okay.
Actually, it launches Preview.
Oh, Preview, yeah.
Which is fine. So it'll show me all the different icons that are in here.
Okay.
Let me actually bring up Icon Composer.
Yeah. I think it's, 2.2, I think, is the version that supports. Yeah, this is funny. Because they show you all the icons of 512, but then they They didn't add it there. They have this little button for the 1024.
Yeah. So, I think I can drag and drop this in here.
Yep.
No, that didn't work properly. Oh. I have to open recent, maybe. Yeah. Okay. There we go.
Yeah.
Well, let me close this one. Don't save it. Okay. So it opened that one. It has a 16 by 16 and a 32 by 32 and a 128 by 128 and a 256 by 256. These ones you're used to from Windows. 512 by 512 is a Mac Store requirement, and 1024 by 1024 is a Mac Store requirement as well. And when you're in the icon composer, you can actually just simply drag and drop or copy and paste the ping files in here. So if I started with a blank one, create a new one from scratch here, and I wanted to create the 1024 one, all I have to do is drag and drop it in here. Save it as an ICNS file, bring it back to the Windows side, and replace the automatically generated icon, or simply go in and just add it as a secondary deployment. And you can deploy multiple files in here. Of course, you can add your own multiple icon files, multiple other files they want to deploy with your application.
And so developers know there is a utility that's in the binary folder on Windows of the install called, what is it, ICO to ICNS.exe?
Yes. Yep.
And right now that handles Windows ICO files. So the team's working on something for the future right now. This is how you're doing it to get those 512 and 1024. ICNS
So files. In maybe in an update or something like that, we'll have the we're working out the UI for adding the 512 and the 1024 icons.
Yeah, and somewhere in one of those build lines in the message window, there's a, when you expand them, you'll see this call to ICO to ICNS.exe as part of the build process when you have a Macintosh target. Somewhere in there, I don't know exactly.
Yeah.
It's in one of those expansion things somewhere.
Yeah, it could be.
So that's how you get when you try to install your application package into iTunes and using the AMP launcher. It's going to tell you that it needs these other ICNS file sizes.
Yep.
As one of the warnings.
Yep.
And
now it says invalid binary. Ooh, okay, that's bad.
All right. And if you go back to the IDE, there's two things that are new in XE3 in the target platform tree. I think it was. There's two. If somebody has a better name, one's called normal.
What do you want to look at?
The platform tree.
Oh, here.
When you're on OS X.
Yeah. So this is compiling and running it normally without code signing for the App Store.
Which means it'll be an app bundle, right? And whether it's a debug version or a non-debug version doesn't matter, even though it has that debug icon.
Right.
And the other choice under OS X is App Store, which is the thing that Andrew's mentioned that will build the package file with the code signing and the sandboxing. So those are new things that showed up in XE3 for Delphi and C++ Builder. These two choices under the platform. And again, if somebody has a better name for normal, couldn't figure out, so they just said it's a normal app versus an App Store app.
Yeah, there you go.
And some of this technology in the ID may not be exactly the same. Will lead us into submitting to the iOS store, right? Submitting maybe to when we do WinRT into the Microsoft store and things of that kind. So the sort of target platform metaphors of the kind of app you're going to build for the target platform is that next level down in the target platform tree. He's staring at invalid binary.
I'm trying to figure out why it says invalid binary now.
Yeah. It also said date.
Oh, you must provide all the required contact information to edit your contact details. Click edit in the app review section. Okay, so I didn't. Okay.
Oh, you didn't put all your other stuff.
I didn't put in my first name, last name, email address, phone number, etc. That's an interesting error, though. It says invalid binary. Well, my app record is actually incomplete. So here you can see the entire app record. I just use this for testing anyway. The app name is Project 1. test app from my use, keywords FireMonkey. There's my blog. You have to have a support URL. You have to put in full contact information. And if you make some kind of account managing software like a banking app or something that has a server-side account, you need to provide a username and a password for that test account.
And all the money goes into what the...
And you have to provide a EULA and all that kind of stuff as well.
And all the money for those apps that you charge goes into what, beer fund or some charity?
Oh, right. Well, for anybody that submits, there's more to, setting up and being able to sell an application. For instance, if you want to sell an application for more than $0 a piece, then you have to fill in tax documents. You have to fill in banking information because they only do direct deposit. Obviously, they're not going to send you a check and all. Do a bunch of paperwork. You have to agree to contracts. These things have to be renewed every time there's a new release of Mac OS 10 or iOS for iOS apps.
But none of that is in the IDE and the application.
None of that is in the IDE. All of that stuff is done through iTunes Connect and your developer account. Yeah. Okay.
There's Ahmed's got a couple of questions. One is back in MathViz, you used a bitmap, pixel, I guess with a pixel array or 1 pixel line to set the offsets for the Y values that you generated, and that lets you color the values of Y there.
Right.
Could you use an image?
Yes, you can use an image.
So any kind of texture, if you want to use I think you were using a T light texture, but you can use a T material source or a texture source or a color source. Right?
Yeah, you can use a full bitmap that is in just one line. You can. This is just one. This was one way of mapping function values, colors to function values, if you will, so that all the Y values have the same color. And it looks nice, but you can certainly assign any other bitmap and stretch it over the. Typically, what you actually do with the texture is that you supply it a bitmap that's going to be used kind of like a blanket, and you drape it over your 3D volume. But in this case, I'm mapping individual color pixels on a line. In this case. To the texture as well. So one of the ideas actually that takes me to the visualizing wave interference article, which is 42115. If you look on the EDN, this has a demo with it as well. This is very simply instead of the functions that we had in the MathViz, this is just a wave function that it takes an amplitude, it takes the wavelength, it takes the originating coordinate x and y, and it takes the speed of propagation for the wave, the velocity, if you will. And then we turn on different waves and we get wave interference. And then, of course, we can go crazy, when we turn up the volume on these different things. One of my ideas was here, instead of doing this, I would actually strap an image of the ocean on here, but that's for later, so that it would actually look like an ocean that's being generated. I wanted to see what that looked like.
Yeah. Otherwise, it looks like some kind of infrared surface of the sun, or
exactly.
Some bubbling cauldron of some kind.
So the point of the wave visualization is actually that it shows you this at runtime, and it goes up and down.
It's like, in this case, dropping a pebble, like a vat of water, dropping a pebble in one corner or in all four corners. You can play with that with the different waveform and where you want them positioned.
And that has a corresponding Code Central entry as well. So I'll update these and blog about them as soon as I can.